Welcome back to my channel. So in this video I'm going to show the practical view of the Ohm's law, which I have theoretically explained in the previous video. I am going to make the feel of Ohm's law. So that's what it is in this video. In this video I might be talking like a robot. Sorry. So in this video I'm going to explain about the practical reality of the Ohm's law. So I'm going to use the software known as Proteus. I already made two videos on this. So this is another video where I'm using this software because it's very easy to understand the circuit using this software. Don't worry, I'm going to make the hardware based video also. That's not a problem at all. So this is the software. Now I'm going to make a new file, means new project. So the new project is here itself. Why did I go there? That's a miss thing. Okay, it's not responding. We will wait for some time. What is the issue? Okay, then I will name it as a Ohm's law. Okay, and I will save it where I want. I'm not going to save it here. I made one separate file for YouTube that I'm going to search in the desktop. Where is the desktop? Here is the desktop. So YouTube Proteus. Here I'm going to save it. Okay, I will save there. Then I have named it as Ohm's law. Then next, default next. Then again next. Then next. Finish. If you are trying it, you also try it with me. So that's the settings what you have to do. Okay, then I want a components. What I want a components? To understand the Ohm's law, we need a resistor, we need a voltage. Okay, I already told how we use a resistor and a Ohm's law. Mainly the Ohm's law is used to either to calculate the resistor by using the voltage and current. Mainly the thing is that we use the resistor to calculate, we use the voltage and current to calculate the resistor so that we can achieve that particular current in our applications. The main Ohm's law uses that, and it is used in the every other law like Kirchhoff voltage law, Kirchhoff current law. There are many other laws which are, I guess there are no laws which do not use the Ohm's law. I guess there might be there, but I don't know. But I feel so there is no such law which do not use the Ohm's law. Without using Ohm's law, there is no law, I feel. So let me take a component by pressing P in the keyboard. Press the P in the keyboard if you are doing it with me. Then next we will take a resistor by typing resistor. So this is a common resistor I am taking. Then okay, this resistor I have got on the this square box. Then I will zoom it. Then I'm going to take an voltage source, again press P. Then voltage we will search. So we get the different types of voltages here. Choose which is very normal one. So let me search fully, that is voltage source. So here it is, which I'm going to take, that is DC voltage source. This I will take. Okay, I will take 2. Why I will tell you now. Then P, we want a ground. Actually ground is not present here. Ground will be present in this L, not in this L. Actually I made a mistake, sorry. I am also using first time. So I guess here somewhere terminal mode, input output, no, here it is. Not this is also not a ground, I guess. No, it's not a ground. It is written here ground, but it is not a ground, I know. Wait, I will search where the ground. Why don't they keep the ground also in the P itself? Or it is there, comment it down, I don't know. Or yes, this is the ground that. Okay, it is present in. No, I came now only, no. No, I was here, I guess. Yes, here is one ground and here is one. What is the difference between those ground? I don't know. You comment it down. Let me take this ground. Then I will connect it. One ground I will connect it here, and one more ground I will one. This also I will take it ground here, and I'm going to, as usual, you might be knowing this. I will connect one here and one more here. Okay. For the simplicity, I will make this as 1 ohms. I have made it as a 1 ohm. So, and both the voltage sources are 1 volt. Now to understand the Ohm's law, what do you feel? The current does it flow in the resistor? We know that what is the Ohm's law? V equal to I into R. What will be I equal to? V by R. So what is the V? That is the voltage difference across a conductor. So now if you take the resistor, what is the voltage difference across the resistor? It is 0, because it's 1 volt. This one V1 is 1 volt and V2 is also 1 volt. 1 minus 1, it is 0. So 0 by R, what it will be? 0 current. So to prove this, I will put one probe here. Let me take a probe, current probe. I could take an ammeter, but who will cut the wire and then who will join it? Best we will take one current probe and connect it here, and you will see the value. Okay, let me run it. According to me, the current is going to be a 0. I am telling this by using a Ohm's law. What is Ohm's law? I equal to V by R. What is V? Voltage difference. What is R? 1. In this case, it is 1. What is voltage difference value? V1 is 1, and what is the voltage difference? Means Ohm's law states that the current the current flowing in a conductor is directly proportional to the voltage difference across it. Okay, that voltage difference here is 0. That is 1 volt minus 1 volt, that is 0. So 0 divided by 1 is going to be 0. So let me run it. According to me, the current is going to be 0. I have used the Ohm's law and I have told it. See, it's a very small value. That is 1 into 10 raised to minus 12. It's a 0.00000001. That's the value, but it's nearly equal to 0. In this software, it might be something internal resistance, there might be something, but it's almost equal to 0. Now we will try one more thing. We will try changing this voltage. Okay, we'll make it as a 2 volt. We will see what current we will get. So now the voltage difference between how much? 1 volt that side, 2 volt this side, 1 minus 2. We should take higher to lower, no? Yes, we will take it as 2 minus 1. 2 minus 1 is going to be 1 volt. 2 minus 1 is going to be 1 volt. 1 volt divided by resistance 1 ampere is going to be the current. And the direction is reversed here. Actual direction of the current was this side. Means going from 2 volt to 1 volt is the current direction actually, because current always flows from higher voltage to lower voltage, that we know. But I have put here, then the current value here is going to be minus 1. Okay, let me run it now. According to our theoretical calculation, the value is going to be minus 1 ampere. Let me run. See, exact minus 1 ampere it came. See, so this is what we use the Ohm's law. We can control the current however we want. But one more thing, in practical situation, this is the ideal condition. This software all behave on the based on ideal condition. In a practical situation, one more thing we have to remember while choosing the resistance value. Okay, now we want a 1 ampere current and we are having the voltage difference of 1 volt. One more thing we always forgot is, that is, does this resistance handle this much of current? Okay, always whenever you go for buying the resistance, there will be a two parameters you must know. One is resistance value and one more thing is that power rating. Power rating is a one more thing which I forgot to tell in the previous video while choosing the resistance. That is P is equal to I square R formula we have to use while choosing the resistance. Now here it is an ideal condition, there is no power rating and all, but in the practical way it is there. So P equal to I square R, what does it mean? I is what? 1. So 1 square into 1. R is 1. So 1 watt resistance resistor you have to choose while using in this same circuit when you are building in the breadboard or somewhere you are using it. Means you have to choose a resistance has register has such as 1 ohm resistor with a 1 watt value. There is a power rating always with the resistance register register. Okay, whenever you go for a shop to buy a resistor, they will ask you two things. One is the resistance value and one more thing is power rating. So let me try new thing, that is I will now we will do what? We will calculate the value of resistance assuming the current and voltage. Okay, now you think such that in this point we are having the voltage of we'll take it as how much? We'll take it as 8.4 volt, or we will take a 9 volt. We will take it as a 9 volt and let it be this 2 volt only. Then we will choose a current of how much? We will choose the current this time. First what we were doing, we were keeping resistance and voltage the constant way and we were calculating the current. Now we will calculate the resistance value. So I have kept the here 9 volt and there we have kept a 2 volt. Okay, then we will choose a current value of 2 ampere. I want a 2 ampere current to flow through this resistor. I don't know the resistor value. We will calculate what will be R equal to? R equal to V by I. What is V here? 9 minus 2. So 9 go 8 go, that is 7, and we want a value of 2 ampere. So 7 by 2. What is 7 by 2? It's a 3.5. So 3.5 ohm resistor we have to use here so that we could get the 2 ampere current. So according to my calculation, everything should work well. Let me see. This also proves that I am using the correct Ohm's law. Okay? See, the value is 2 ampere. See. So this is a main application of Ohm's law, to choose the resistance value or to choose the current value. Because voltage we will be already knowing what is the value. So I guess there might be no choosing of voltage. We can choose the resistance, we can choose a current. So this is a very important application of Ohm's law. You can play around in the same way. We can do one more thing. If I want the 3 ampere current, what value of resistance I am going to choose? So the voltage difference is same still, that is 7. So we want a 3 ampere current. So 7 by 3. What is the 7 by 3 value? It's a 2.3, I guess. Wait, 7 by 3, no, 3 2s are 6. Okay, 2.3. So the value is 2.3. Let me put here 2.3. According to our calculation, the value has to be 3 ampere. Let me run it. We will see what we will get. See, it's a 3 ampere. So that is what we will use the Ohm's law for. So always remember, while choosing the resistance resistor value, we have to keep two things in the mind. One is resistance value and one more thing is power rating. Power rating is very important. See, if I am choosing the 2.3 ohm resistor and I am passing current with 3 ampere, then we have to use the power formula, that is I square R. What is I here? 3 square. So 3, I is 3. So I square is what? 3 square. That is going to be 9. 9 into 2.3. 9 into 2.3 is going to be around somewhere around 18 or 18 to 19 watt. So we have to choose the resistor with 2.3 ohm and 19 watt value. So this is power rating. So that's it for today. Thank you.